Welcome to another episode of the Distributed Data Show, brought to you by DataStax Academy, where we bring you the latest news and interview technical experts to help you succeed at building large-scale distributed systems.
Hey, it's Jeff Carpenter here again with Josh Perryman from Expero. It feels like so long since we last spoke.
I've gotten through a full laundry cycle myself. It looks like you've done the same.
Yeah. Brushed my teeth a couple times. But today is a new day, so to speak. Last time when we talked, we got a bit of your history on how you got into graph databases in particular, and like kind of how that voyage of discovery that you were on, and some of the discoveries that you had around when to use a graph database, what it really excels at, how you mix graph databases into your solution, and what parts of the problem you choose to apply your graph database on. Spoiler alert, if you haven't watched that or listened to that episode yet, it's more on the read path in Josh's experience. So what I want to talk about with you today is basically like, where are we at now in the world of enterprise data architecture when we're kind of building large scale systems and thinking in particular of the data tier, like what's the state of the art right now that you see in industry, and then where should we be going? Where are we going? Where are we headed in the future? So what do you think?
So state of the art, I know where a lot of enterprises want to be, but I know where most of them are is they're still working with their relational databases. And I think that's a really good thing in large cases, because that's a known and well-established technology area. Where we see them running into problems is when they start scaling or running into places where they're read-intensive environments and the relational databases are third normal form, and every single query is going to be multiple joins. It's too much to do at runtime.
Yeah, and so that's when you get the phone call, is when they're pushing up against the limits of what their current database or data layer can handle. Is that right?
When I look at particularly my last 4 years or so of working with different development groups, because I don't work with product owners, I usually work with development teams. It's going in and helping them with to expand their existing tool set. They know their relation databases well, but when they get to a point, and we do this all over the place, where we have our tools for solving problems, and we have our common patterns for addressing those. But when our problems get too big, or they change dramatically, or our business requirements may change dramatically, and we may have huge amounts more data than we were expecting, or some other major shift, that's when we need to expand our tool set. And that's usually when I get to come in, because I've been working with a variety of different tools and working in those problem areas. And so I get to kind of come alongside those other developers and say, hey, here's a really amazing technology that DataStax has built. Let me show you the right way to use it so you don't get hurt in the process, and we actually solve the problems and you don't get frustrated.
So what's the tool set? Spill.
The tool set, a lot of this. Okay, so, when I come back to this, and I've got some great points along the way, a lot of it is understanding what's happening at the persistence layer, or understanding kind of this full stack. I was in Denver a couple of years ago working with, I can say it was Comcast, because they actually did a talk about the learnings that we went through there. And they were on their third graph database engine, and they were looking at a scale out solution. And I talked with them what they had learned up to that point. I'm like, yeah, you learned a lot. So let me show you how to use DataStax Graph to solve this problem. And I went toe to toe with the architect, really, really sharp guy. And he says, no, that's not the way graph works. I'm like, well, we're not really modeling for graph. We're modeling for Cassandra here. And this is kind of the tool set. And this is what I learned so much from going through the DataStax Academy courses, really, and DataStax Bootcamp and other things, was we model for our access patterns, and you can really optimize for that. And when you do that, you are now able to, and when you give up on joins as well, you're able to do some amazing things in performant ways across multiple machines. What was really neat about that experience in Denver was kind of talking with them and saying, okay, here's some of the trade-offs that we have to make from our graph design point of view. But when we do that, we're using Cassandra really well underneath, and we're still able to reason over our data in a graph way. So it was a bit of a twofer. We got the performance benefits from Cassandra and the scaling benefits. But we were able to think about and reason in their domain in a graph way.
Gotcha. Okay, so it sounds like state of the art where we're at in industry is in a number of places. Maybe not every company. Not every company has massive data sets or massive scale out problems, but we're seeing companies that are needing to scale beyond what they can get from the traditional relational database, even with recent advances and offerings from a variety of sources, still running into those. And what you're doing is not only applying graph databases to those problems, but it sounds like a graph solution built on Cassandra, to the extent that you actually need to think about what you're doing with your data model in order to get the scale. It's not just a pure abstraction that you can just drop in and say, okay, I can create whatever data model I want and expect it to scale well and perform well.
That's exactly the conversation I had in Denver. Because they're saying like, no, we just need to use it as a graph database. And like, no, you can do that when you're dealing with toys and when you're dealing with small data sets. But when you start dealing with interesting levels of data, you have to start thinking about data locality. Where is my data located? And if I'm going to be querying two pieces of data regularly, I want them to be on the same device, or better yet, in the same table, or better yet, like on the same partition of disk.
Right. Oh, so that's the secret sauce then.
A lot of it comes down to understanding what's happening at that low level, at the disk layer. Where is my data? What node is in the cluster is my data on? Within that node, where is it on disk? Data locality. That's oftentimes what I'm trying to optimize for, except when I can't. And there have been cases where I can't.
Of course, yeah. But what it comes down to ultimately is I need millisecond latency on my query that I'm trying to serve. I have a massive data set. It's spread across multiple nodes in a cluster, and I want to do as few reads as possible across, literally off of disk, or maybe I even have stuff cached. But I want to be doing as few data accesses as possible to get back the data that I need, so I can meet my SLA. That's what it comes down to.
Yes, those are the environments that I get to work in. I'd love to be in some week-long batch processing position where like the performance, they want to submit on Monday morning and get results by Friday. That would be kind of fun. Maybe it's interesting for a while, I'm sure.
Oh, I don't know. I'm not sure that you would find your fulfillment there, but.
No, I think you're right.
We'll see. Yeah. So okay, so let's turn our gaze to the horizon here, and where are we going in this world of data architecture? What's going to be happening, or what kind of problems are you going to be solving down the road? Just like kind of take us there. What does it look like?
Well, and this, I'm standing on the backs of giants with this, because there's some incredibly talented people that are writing about this and and I'm trying to follow on with them. And then I'm interacting with some really top-notch architects at different client sites. So this is, I just have to preface by saying this is a really limited view of where things are going. But one of the things that has struck me before I got into Graph and the Cassandra world and the DataStax world, I was into kind of performance for relational databases. And when you start working there, you start looking at how does a relational database, is it constructed? How do they achieve under the covers? What's going on under the covers, right? So in typical, a relational database will have its main data store, and then it will also have a transaction log. And then it keeps those things consistent, and then it provides a really nice, through SQL, an abstraction over that. And maybe it also includes a full text indexing or some other things. All of these parts are happening under the covers. And what I see going on in the world now is that we realize that the relational database package is a beautiful thing for a certain set of problems, but in some cases, we only need parts of that. And in fact, we'd like to relax the ACID constraints, or maybe we don't really need joins because we're comfortable enough just having a different separate table for every single access pattern that we do. So at a high level, what I'm seeing is a deconstruction of the relational database, and we're beginning to pick and choose technologies that will allow us to build kind of boutique solutions for these big data areas.
Okay, so what does that mean, deconstructing the relational database?
So Cassandra is a great persistence layer, and you can do all sorts of amazing things, particularly like storing time series and other stuff in there. But it's really awful for a queue. The anti-pattern there. We don't want to do that. And you can't do joins. And but there are times where I want to bring this stuff together. So one of the kind of the simple steps, if I'm wanting to join together or bring together data now, is we've got DSE graph, and so we can throw graph in there, and now we've got if I'm just reading a set of rows or a set of stuff, I can do that. If I'm wanting to join, I now have this graph abstraction layer in there, so I can do joins. But what if I'm wanting to do something like a queue or a transaction log, that type of pattern, and perhaps I want to replay that multiple times? Well, now we've got Kafka coming in, and we now have these streaming solutions.
Right.
And as I was reading into Kafka and understanding how Kafka was working at the very low level, I realized it was extremely similar to what the relational database people had been doing for years in terms of the management of the transaction logs. Kafka works in a very similar fashion to how the relational database vendors, I mean, Kafka, they optimize for the use of the file system as a file system, and then they kind of abstract away from that. But under the covers, that's what they're doing. So under the covers, Kafka is really operating a lot like relational databases are operating very close to the metal, and they're working with that file system very closely. Kafka is doing the same thing. And if you look at the design of how relational databases have optimized their transaction logging infrastructure and compare that to how Kafka has built its infrastructure, they're very similar. And so I'm seeing now as any type of use case where I would want to optimize my use of a relational database transaction log, I can almost yank out that code and replace it with Kafka and get a lot for free. All of the Kafka benefits in there. So I think we're dealing, like one of the next things is we're now dealing with relational databases, or we're now dealing with our data set not just as a store of state, but as a stream of events.
Okay, I gotcha. So yeah, what I'm hearing from you is I think that we have a number of new options that are available to us. And it's not only the relational databases, those are still around, but we also have some of these NoSQL or not only SQL tools like Cassandra that came into the mix, but then also we have streaming technologies, we have Kafka. So now we have all of these things. And I'm contrasting with maybe architectures of the early 2000s where maybe we had a relational database and then we had like a message broker, like a Java message service or a message queue kind of thing. And then those were kind of our data at rest and moving data around asynchronously, let's say asynchronous message passing. And then those were kind of like our two main choices. And we picked a database and we picked a message broker and we were done. Now you're telling me I might have a relational database, I might have a couple of other databases, a graph database, a message, I might have a message queue or a streaming or multiple streaming sources coming in. This sounds like a lot of complexity coming in. So how do we manage all of this in this sort of, I guess, maybe what we're calling the polyglot persistence world?
That is a great question. Maybe we should have a part 3 and I can research it and answer it. I just build these things. I don't run them. No, there is a lot of complexity with this, and what one of the interesting areas that I'm beginning to cut my teeth on is how do you manage that complexity? Because now you've got multiple solutions, multiple schemas, multiple versions of things in a big dependency problem that's coming along with this. And so that's where, I start talking with developers that are wanting to go down that path. I'm like, okay, well, you need to understand you're trading, you may be robbing Peter to pay Paul with this, because you may solve your monolithic problems and now have decoupled all parts of your infrastructure, but at the same time, now you're loosely coupled or coupled in strange and unusual ways, and it becomes really difficult to reason over that kind of disperse of an environment. You've got too many moving parts to keep track of. And so I think we're going to be developing some tools for managing schema versions better and syncing those up between different things. We're going to have to be very firm in terms of how we build our interfaces and we establish our contracts between things. We have to be really clear in terms of where we establish those contracts. We need to be really clever in terms of and maybe this is also luck in terms of defining those boundaries, those service boundaries or other boundaries between these things. Because if we're not careful about those things, we're going to shoot ourselves in the foot, and we're going to run back to the monolith.
Right. Maybe we'll go back to writing big XML schemas for
Right.
middle school. Never mind. No, we're not going to do that. No, but yeah, and I guess to throw some other ideas in the mix there, because I can and because I'm asking the questions. No. I think that there may be some place for some analytical solutions to this kind of thing to be able to go in and use analytic tools, Spark, what have you, other platforms that allow us to kind of aggregate data across multiple sources, maybe sometimes in real time, maybe sometimes in not quite real time, to really kind of be able to go in and look and see what's happening across multiple data sources. Or maybe we're going to end up doing more distributed tracing and kind of as we trace the path of a particular piece of information through the system and all the different databases and queues and streams that it ends up in, to just kind of watch what happened with a particular business transaction. I think there's a number of different creative solutions that are going to start coming into play there.
Yeah, I agree with you with that. The distributed tracing is going to be that's going to become essential as we decouple things. And I'm curious. I haven't thought about this yet, and I've got some guys that they know this technology area better than I do, and I'm wondering if with that analytics we could marry that with some machine learning or something else to better, and perhaps as a way to understand and optimize our environments, our complex environments that we're managing.
Oh, absolutely. Watch this space, I think is the word on that one. Okay, as we often tend to do on the Distributed Data Show, we have an ongoing conversation with many voices in it, and I think we'll stop ourselves for today and leave that topic on the table as a tease for a future episode, because it legitimately is an ongoing conversation that we have here in a rapidly changing industry, in a place that is fun to be, honestly, from a technology perspective. So, Josh, we've really enjoyed having you on the show, and we're definitely leaving some teasers out there so we can have you on in the future to talk more. I want to hear, once you've learned the secret to managing the complexity of all these different tools, I want to hear some of those secrets. So.
Yeah, well, I've got to thank you very much, Jeff. This has been a lot of fun. That really is the frontier I see as next, as we've deconstructed this database and we've blown everything apart, and now we've got state in multiple places and projections of our data and lots of different processes interacting in strange and unexpected ways. It is the Wild West out there, and that's, of course, is where I'd like to play. And thank you for this opportunity to talk about that.
Excellent. Well, at this point, we will ride off into the sunset of our Wild Wild West here. And thanks for watching this episode of the Distributed Data Show. See you next time.
Thank you for joining us again for the Distributed Data Show. We love your feedback, so go to the Distributed Data Show page on DataStax Academy and tell us what you think. You can also find us on the DataStax Academy YouTube channel, or find our podcast on iTunes, Google Play, or wherever you get great podcasts. While you're there, make sure and subscribe so you don't miss a single episode.